Now I will tell you two important properties. First is, if fx is an even function, then limit LHL is equals to limit of RHL, means left hand limit must be equals to right hand limit. I will write it down. P1, property 1. If fx is an even function, then limit of x tends to 0 minus of fx must be equals to limit of x tends to 0 plus of fx. In short, we can say that LHL is equals to RHL. Properties number second. If fx is an odd function and limit fx exists, then limit of x tends to 0 of fx is equals to 0. Means if fx is an odd function and fx, limit of fx exists, then limit of x tends to a of fx is equals to 0. Okay, these are the two main properties. I have tell you about the greatest integer function, existence of the limits. Now I will give you some questions. Here our given question is limit of x tends to 0 over x upon greatest integer of x. Here this x is the greatest integer function. In this lecture I have tell you about the concept of greatest integer function. Step 1. First of all, you have to find the left hand limit and right hand limit. Clicking the partition. Limit of fx and x tends to 2 minus. As I have told you that in left hand limit the approaching is always negative, and in right hand limit and approaches is always positive. So we can write that limit of h tends to 0 f of 2 minus h. We can say that 2 minus h over mod or greatest integer of 2 minus h. As I have told you, the property of greatest integer function, like this one. Are you getting this? What I want to say? N plus is n, limit of x tends to n plus is equals to n. The limit of x n minus 1 of greatest integer x is equals to n minus 1. In this case, this is the second case, so it would be 2 minus h over 1. 2 minus h over 1. So limit h tends to 0 is equals to 2. Similarly, in the right hand limit, limit x tends to 2 plus of fx and limit of h tends to 0 f of 2 plus h is equals to 2 plus h over greatest integer of 2 plus h. As I know, 2 plus h over 2 according to the property of greatest integer function. It would be 1 plus h upon 2 and limit of h tends to 0. It would be equals to 1. Here the left hand limit is equals to 2 and this is equals to 1. 2 is not equals to 1, hence limit said to be does not exist. Limits does not exist. Now second question. Our second question is, show that limit x tends to 0 mod x upon x does not exist. Here I will tell you one thing. Here fx is equals to mod x upon x. I will tell you about the property of mod x. The value of this will be equals to 1 if x is greater than 0 and its value is equals to minus 1 if its value is lesser than 0. Are you getting this? Now again we need to find left hand limit and right hand limit. So for left hand limit, limit of x tends to 0 minus of fx is equals to limit of h tends to 0 f of 0 minus h. It will be equals to minus h upon h. It is equals to minus 1 limit h tends to 0. Okay, for the right hand limit x tends to 0 plus fx is equals to limit of h tends to 0 f of 0 plus h. It would be equals to h upon h is equals to 1. Minus 1 does not equals to 1, hence LHL is not equals to RHL, hence limit. Now I will tell you the concept of limit by doing it in some simple steps. As according to the given question, fx is equals to x if x is an integer having any integral value, or fx is equals to 0 if x is not an integer, to show that limit x tends to 1 of fx is equals to 0. So its solution: limit x tends to 1 minus of fx is equals to limit of h tends to 0 f of 1 minus h. You can write that limit of h tends to 0 of f of 1 minus h must equals to 0, as it is clear 1 minus h cannot be an integral value. As we know, h tends to 0. Its value is near about to 0 but not exactly 0. Let's assume 1 minus 0.001, its value will be equals to 0.99 or something else. It would not be an integer, hence 1 minus h cannot be an integer. Similarly, in the right hand limit x tends to 1 plus of fx, it implies limit of h tends to 0 f of 1 plus h. 1 plus h is also not an integer value. So we can say that limit of x tends to 1 fx is equals to 0. As left hand limit does not have any integral value, similarly right hand limit does not have any integral value, we can assume that limit of x tends to 1 of fx must be equals to 0. Now second question. Our next question is limit fx is equals to cos of greatest integer x when x is greater than 0, or mod x plus a if x is lesser than 0. This is a previous year question from IPU 2013. According to given question, find the value of a given that limit x tends to 0 fx exists. It means limit left hand limit is equals to right hand limit. So by using this concept we will proceed. So as according to the given question, LHL is equals to RHL. It means limit x tends to 0 minus of fx must be equals to limit of x tends to 0 plus of fx. Okay, are you getting my point? Limit h tends to 0, 0 minus h is equals to limit of h tends to 0, 0 plus h. As they are equal, now putting the value of fx, limit h tends to 0 mod of 0 minus h plus a is equals to limit h tends to 0 cos of mod greatest integer of 0 plus h. As it is mentioned in the question, if its value is lesser than 0, then it's mod x plus a. When its value is greater than 0, then its value of cos of greatest integer x. So now using the concept of the greatest integer function, we know s tends to 0. So a is equals to cos of 0. Cos of 0 is equals to 1. Hence the value of a is equals to 1. Next question. According to our next question, limit x tends to 0, e raised to power 1 by x minus 1 over e raised to power 1 by x plus 1. Now again, left hand limit x tends to 0 minus limit s tends to 0, it would be equals to e raised to power minus infinity minus 1 e raised to power minus infinity plus 1. As we know, 1 upon h means 1 upon 0 is equals to infinity. So e raised to power minus infinity minus 1 over e raised to power minus infinity plus 1 is equals to minus 1. Similarly, in the RHL, limit of x tends to 0 plus of fx is equals to limit of h tends to 0, it would be e raised to power infinity minus 1 over e raised to power infinity plus 1. 1 minus 0 upon 1 plus 0 is equals to 1. Here its value is minus 1 and here is equals to 1. Left hand limit does not equals to right hand limit, hence limit does not exist. If you enjoyed the video, please leave a like and also subscribe for more.